Hey guys.
Okay.
So I wanted to, especially since some of you guys are newer to the team, I wanted to go over manufacturing methods, a brief review of them, and sort of what you guys should think about that you can do during the year, and what you guys think you want to learn is kind of the big thing. So, yeah, there you go.
Nice.
So, first thing is I want to talk about common materials and manufacturing techniques that are used in general FRC. Material often doesn't come up, but sometimes when you're in weight crunch situations, it can make a difference if you understand why you're using a certain material in a certain situation. This came up last year a little bit in terms of why we had steel shafts versus aluminum shafts, why you wanted to use 1/8 inch wall versus 16th inch wall, this type of situation. Overview of the different tools that you guys have in your shop for manufacturing. You guys actually have a really amazing shop, and I'm really jealous because my FRC team had a chop saw. That was it. We had a chop saw and maybe a drill press. So some common design pitfalls that you guys will often come across, like during build season, like how you can have this great idea and then how it cannot work, and then why you should buy COTS parts. Ian has a whole presentation on this. I'm not going to go into it in great detail, but that is an important thing to consider too when you're making the rest of these, like when you're using your manufacturing stuff. Right. So overall, you have a bunch of different things that you're going to see. Aluminum is by far the most common. We tend to use aluminum 6061. And the reason I'm going to say that specifically is because if you go on McMaster and you say you want aluminum, they're going to come up with a giant list of spreadsheets for you. I don't know, have any of you ever looked on like McMaster or Online Metals? Okay. So I'm saying this specifically because in general 6061 is a standard aluminum that comes in most sizes and what we want. And it's a pretty good density ratio to strength that you want for FRC. You will also see that they have different types of aluminum listed, so I'm telling you that in advance. You also have your polycarb, your plastic, steel. Limit on a few occasions you will actually have steel, and you have wood. Last year, I don't know if you saw it at CBR, they actually had a completely wood robot that they laser cut and tried to assemble in a pit. That was cool. I actually admired that.
For aluminum, I think the reason we do 6061 is because it's relatively easy to machine, it's relatively cheap, it's reasonably priced, and it's weldable, so like there's a bunch of reasons why teams use it.
Yeah, 6061 is by
and
far.
then 5052 is what we use if we want to bend it into like a sheet metal part.
Yeah, and then I think you can use 7076 if you want it to be stiffer, but don't want to. It's 7076, I think.
7075?
7075. Yeah.
7078? I don't think they make that. But yeah,
Yeah.
7068.
Yeah.
It actually means something. Well, some of them are arbitrary, some of them mean something.
It's a 7,000 series that's stiffer.
Yeah.
That you can use.
Yeah, we use 7075, 6061, and 5052.
Yep. So.
Something like the first number is like the ally mix, which is how you get these different grades.
Same copper.
And then basically within each grade, there's only like one or two sub variants that people actually use, which are the ones that are stocked.
Yeah. I would
so 5, 6, 7.
I would highly encourage you to go onto Online Metals or McMaster or someplace like that and start looking and reading those catalogs, and we can go over that today if you guys want to. This is a brief presentation so you guys can ask questions about what you actually want to learn about, because I don't know what level you all are at. I made it so that we could talk and not just me talk all the time. But first we're going to start with cost, because this is a really important thing when you're doing manufacturing and when you're doing design. Things that you often buy are bearings, gears. You don't make your own screws, right? These are things that it's really important to know about, because when you're trying to create a robot or design a robot, or for instance, you guys have been putting together the e-board, right? What is something that you've run into that's been a problem? It's a really obvious answer. Like, you guys were struggling with this last week. So Trinity, when you guys were trying to screw down things, the screws were too long, weren't they? Right? That's a small thing, but it's important to understand what you have in stock and what you can use so that when you start manufacturing the rest of the parts that you want to make, right? Because you can't just, well, I mean, I guess you could try, but you can't just buy a full robot fully assembled, right? You have to kind of put some stuff together.
We used to not be able to.
Right. So it's important to know what you have on hand so that you know what you should be trying to manufacture and make going forward, right? And the other thing is, especially for some of you guys that are more interested in learning AutoCAD, or like SolidWorks, Onshape, Alan's played with it?
I have it on my computer, I haven't really opened it.
Okay,
It's hard.
that's good. It's okay. We can go over all of that too, because this is really important for later on. If you're using like gears or bearings or motors, right? They've been talking a ton about motors and gear trains and all of that. These two guys have done a great job. Sometimes they'll have files that you can download and put into your CAD model. And I highly, highly encourage you guys to do that, because that'll allow you to design and manufacture the parts that you need going forward, right? For instance, why does this matter? Say you need a hole to put a shaft, and you're going on, you think, oh, the shaft needs to be 1/2 inch. You find out that it actually is too big, and now you can't fit the shaft in there. Hey Ben, we're going over cost parts and basic manufacturing methods. If you have any questions, just jump in. This is a discussion to get you guys thinking, not a, what's your question?
What's this McMaster-Carr place that we keep talking about?
McMaster-Carr is an online website that we buy a lot of our materials from. It's
You can buy toasters from Master.
it's great,
Yeah, that's
isn't it?
true. Use your own or robot?
Sure,
Yeah.
yeah, just pots.
It
No, you
is
cannot
cotton.
legally put a toaster on your, well, okay, you can't put a Howard toaster on your robot. That's against the rules.
Yeah.
No, custom circuit.
It's over 40 volts.
So McMaster-Carr is a great place, especially if you are just trying to find out what sizes for your stock parts are available. So when you want to manufacture something, the other thing that you need to do is buy materials, right? You need the aluminum, you need the plastic. So even if you don't buy it from McMaster-Carr, they actually have really great specifications that show you what sizes are available. In manufacturing, they manufacture things to set sizes and set amounts, because it's more cost effective for the big metal manufacturers to do that. Make sense? So I don't think that you guys, what's like an odd decimal
Well,
that you can buy like a thickness
So
or
probably a good
something?
example is that you can't, well, so there's different grades, like the McMaster catalog is huge, right?
Mhm.
So you can buy, if a certain size of aluminum extrusion doesn't exist in the McMaster-Carr catalog, good chance you probably won't find it somewhere else. So like you couldn't find like 2 by 1.75, like forget it. But you can find like, what did we, last year we used
5x3.
1.5 by, oh yeah, there's 5 by 3, which I used before on a different project too, but, and then the thing where it slid inside of the other thing, that was like 1.5 by 0.75. But for example, that was in the McMaster catalog, but not on online metals.
So McMaster-Carr is generally the best place to see if a size exists. Cool. Any other questions? Next, let's talk about what you guys can actually do in your shop. So I mentioned earlier, and I'm pretty sure that both of these guys have great stories about how we manufactured things with a chop saw and a bandsaw and maybe a drill press. Right. You guys have a lot of capability here, and this is really awesome. And the biggest thing is you guys need to get comfortable using these tools. So you have a bandsaw for both wood and metal. You have a metal press. You have a mill. you have, I think that you can use one of them as a sand mill, one of them as a CNC mill, and then you also have the table router, so you actually have like 3 different mill capabilities. You also have a CNC lathe, which is really nice. You have a hacksaw, and if you guys were listening earlier, 3 of us are trying to plot on getting you guys a 3D printer, but for now, I brought in my 3D printer that you guys can play with afterwards. I wanted to have you guys have some fun and sort of see what you can do with it. And we're gonna go over a little bit on what you can do with each of these tools. These are really brief, so please ask questions if you're not sure. And if you wanna learn how to do them, please ask us too. This is about what you guys wanna learn and how you can do it. Okay? Next, so the CNC and the lathe, why would you wanna use a CNC or a lathe? Because these actually require a lot of upfront planning and a lot of upfront time. Because you generally need to have a 3D model that you can export to create G-code, or what the machine understands to create a pattern, generally using a software called Mastercam, right? So I have 2 people that said that they had SolidWorks and Onshape. We'll call them one and the same at the moment. How many of you guys had done CNC Mastercam? We got Alan.
Do you mesh cam?
Meshcam, yeah, sorry. Doing good. Meshcam. Okay, so we have Alan. Okay. How hard was it to learn?
It wasn't too hard when I looked at David's tutorial, but before I tried to use that, it was pretty hard.
Okay, great. So there are resources available. I definitely encourage anyone, especially who wants to go into a lot of like mechanical engineering, to learn this. It's going to be really helpful for you in college and beyond and now. So this is great. You can use it a lot. You use it a lot with metal. You can also do some routing on wood. There's some like harder plastics like Delrin and things that you can use for these. You want to use this when you need what?
Polycarb.
And polycarb, yeah. And you want to use this if you need something to be precise, if you need something that you want to be repeatable. So for instance, all of the hole patterns that you see, if you need those holes to be in a certain location, it's a good idea to have them CNC'd instead of hand drilling them, because the CNC's accuracy is a lot higher than us. We're not that cool, sorry. I mean, I have a friend that can actually do it pretty well, but that's a lot of skill. A CNC takes that out. And then the last reason that a CNC is good is it allows you to keep manufacturing parts over and over again if you're going to need them multiple times. For instance, a lot of the plates last year, right? We had to make, I think 4, 5, 6 of these overall. So it was really easy once all of the front work was done to keep running a CNC pattern over and over again. It can be more time efficient if it's precise, if it's going to be a critical component. But you don't always need to do this. You can also use the non-automated tools. And this is important too, right? If you need to do a quick hole, if you need to just cut some metal to be a length and it has a like, I don't know, you can probably get it within like a 16th of a tolerance, maybe quarter inch. Depends on the size of the tolerance you need, but it's okay. You don't have to CNC everything. That's the other side of having such a great tool set, is you need to understand when to use it, right? So, for instance, when you guys were making the holes on the e-board, right? There's no reason to CNC that. You can drill them out with a hand drill. I mean, you can do it either way, but that material you're using also like pretty easy to drill out, right? Yes? No? Questions? Okay, so the other big reason that these tools are great is they're really good at creating fast prototypes. Sometimes, say for instance, you just want to see if a test theory is going to work. Cut 3 pieces out of wood, put it together. It can take like less than a meeting, right? Getting a full CAD design done, getting the G-code written for the CNC, that's a lot of upfront time for a quick prototype test. There's some times that you actually just want to keep testing things and iterating on them versus doing a full design. More complex components, you might wanna do some CAD work. This is something that we can help you as you go through the season, kind of deciding when is it better to just test things versus when is it better to actually sit down and design something, right? It's a little bit of a nuanced thing, but definitely think about the tools that you have in the shop as great ways to get prototypes out, cut things quickly. If you need to build field components, this is a great way to do it, right? Because generally those are just big pieces of wood that you just need to cut up kind of quickly and just start drilling them together, screwing them together. So, large, not automated tools, great resource you guys have. And it also helps you cut down the metal to whatever size you need if you're going to go to a CNC later, right? Because sometimes the CNC has a bed. It can only fit a certain amount of material in there, and sometimes the stock material that comes into the store is not the size that you need for your CNC part.
We actually have to be fairly careful about that because, the one manual capability they didn't build into the shop was, cutting down large flat sheets of aluminum.
Yeah.
There's actually no tool for that in the shop.
Yeah.
You could put,
We could,
put
Because-
aluminum cutting
Or you can
plate
hand
on
saw.
the table saw.
yeah, we
Not on a
can.
saw, not on a saw stop, no.
Really?
It'll set off the saw stop.
You just turn off the saw stop. Yeah, imagine.
Okay, fine, you're not really supposed to do that.
So,
This came up when we were ordering, that's why I wanted to mention.
yeah, so that's a good thing to remember. But let's say the cutter in the back with the lubricant can cut some of the
Mhm.
metal pretty well. So if you have like long tubes of aluminum,
Yes,
that will cut through fine,
for sure.
right?
Mhm.
So, how many of you guys have used the bandsaw? Yay! How many of you have used the drill press?
Excellent.
Great. And hand drills and other screwdriver type things? Awesome. So you guys, how about this? How many of you feel comfortable using these tools?
Some of them. Everything
Okay.
except for the bandsaw.
Oh, okay.
Okay, that's good. That's a really good start. We can get you guys on to the harder tools and we'll get you guys practicing with them. Okay, so the last one is using a 3D printer. So 3D printers have finally gotten to the point where they're affordable enough to use kind of at this level, right? For a long time, 3D printing was very, very expensive and not really worth it for teams to buy them. These are really great for custom parts that you need, and especially components that are not under a lot of stress. Plastic, especially the 3D printing plastic, is liable to break if it's put under a lot of stress. So you don't want to, for instance, to have a gear 3D printed that's going to be taking a lot of torque, because it could break, it could fracture, and then you're out of the gear train. That is something I really want to stress, is 3D printers seem like a great way to make all of these parts and components, but there are times when you want to actually have it be metal, have it be COTS, have it be some other type of material. Just because you can make it on a 3D printer doesn't mean you should, right? That's the most important lesson out of 3D printers, and it's something that Ian and I had a lot of experience with when we were in our college robotics team. There was a lot of people that were like, I'm gonna 3D print a box. I'm gonna tell you right now, if you're 3D printing giant boxes, I will nix it. It is not gonna happen. There's this thing called make MasterCard, order the box. Like, it is already made. 3D printers are great for these complex custom parts. A big one that you could think about is camera mounts, right? A camera mount is actually a great component to 3D print. Hubert, if he was here, had a part I wanted to 3D print with him today as your demonstration. So the other thing is 3D printers will also require a software that you need to have on your computer, and you have to have that set up. And because of how a 3D printer works, you actually sometimes either need to create base plates or support structures in the design, because sometimes the design is sort of complex and it actually can't support itself when you're printing. So every single piece of, I have this word for it, like, I call them trees, little tree branches or the support structure. You do have to take all of that off once it's done printing, depending on the complexity of a part. I have a great example of it. I printed my friend a dinosaur to make sure my printer worked, and the support structure was on there so well it took the dinosaur's foot off because I couldn't get the structure off. So and this is like also me trying to figure it out, right? So you do have to consider that there's a big start time and a kind of a ramp time down for making these components. They're great and they're really good. Just remember that. And then the last thing is that some of these components, they will take some time, right? If you want a 3D print a part, it could take hours, depending on the resolution, depending on the quality, and depending on the structure. This is stuff that we can get into more if you want to. But overall, a 3D printed part is not an instantaneous part. That's the most important thing to consider. If you have a flat piece of plastic that you want to cut to a specific shape, I would actually recommend trying to get the laser cutter to work, because the laser cutter can actually create it a lot faster than a 3D printer can. Also, the last thing about 3D printers is you're limited by the size of the bed on your 3D printer. And 3D printer beds are actually not that big. Like my bed on my 3D printer is actually pretty small, it's like this big. It's not that big. So you can't make these giant monolithic parts overall, unless you're SpaceX and you have like the $10,000 printers, which we don't have. So that's that one.
I have a question.
Yeah.
What kind of file would you like transport into 3D printing?
You generally need an STL file, but sometimes the printer will tell you what type of file type it wants. In SolidWorks or in Onshape, there's a way to export these files. So instead of it being a SolidWorks part, it's an STL file, right? You save it as an STL file. Then when you're done, you import the STL file into the 3D printer software, which will then, once it's composed that, save it. My 3D printer actually works, you can stick a USB drive in it and then print from that. It's very handy. And it will have, once it's gone through the software, I'll save it onto the USB drive and then it'll save it in the file that the printer can understand. That's it, yeah.
So what kind of materials do we get with these, like, with like the low end printers, and how does that compare to like machinable materials?
Okay, so in general, my printer can do PLA and ABS plastics. So they're going to be lighter, less, what's the right word for it? They're lighter plastics. They're generally, you can, if you apply the right amount of force to them, you can actually break them by hand, right? It
Yeah.
depending on the structure, right? I mean, if you have a solid block of it, you're not gonna do that. But, so PLA and ABS are generally lighter plastics. They do have lower melting points, right? So you don't wanna put them in any thermally stressed environments. Not that we have that here, but, I think about that stuff too. Whereas like a Delrin, for instance, is a much harder plastic. It can withstand a lot more, and that actually is very machinable.
And
Right.
laser cuttable?
And laser cutterable. So that's a component of where if you have a Delrin type plastic, it's a lot harder, it's a lot stronger. It has a higher Young's modulus, which doesn't mean anything to you. So I'm trying to think about how to say this in a not completely over the top way. It's
Maybe brittle, it's less brittle?
It's
like
less
PLA
brittle.
is particularly brittle, and then
yes.
like if you make, and it's kind of hard to compare it to polycarb, but like Delrin will
Delrin.
bend before it breaks.
Yes, and PLA and ABS, especially PLA, it goes under a certain amount of stress. So for instance, in metal, if it goes under stress, it starts to bend, right? It doesn't crack. But if you have a ceramic bowl, it cracks. PLA acts more like a ceramic bowl in this situation. It's going to crack, it's going to break, whereas the metal will have a lot of yield before it breaks, right? that's the reason that I'm saying you shouldn't use this in what I would call critical components to your robot. If there's a chance that this thing could get rammed, slammed, broken, and it's holding something very important, I would not advise using especially PLA and ABS plastic for it.
ABS is fine.
You can use ABS, but it,
ABS has its own problems.
Yeah.
You're probably, yeah.
it's just something to consider. So like, but Delrin is machinable. Actually, if you look at the rollers that we have from last year, those were Delrin, right? Those were machined on the lathe, and they worked really well, right? And those were plastic. So that's good. What other questions? No? Okay. So the last thing I want to talk about is some common design pitfalls and remedies. Some of these are from self-experience. Totally true. So the first thing is when you make a CAD model, if you are going to take the effort to make a CAD model, please try to include at least placeholder pieces for almost all of your components, because CAD models halfway through a season start to become not guidelines but law. Unintentionally sometimes, right? But if a CAD model is a way to transfer information from me to you, right? It's so that you can see what I'm thinking. Kind of fundamentally at the end of the day. So if I know that we need to have a shaft, or a shaft has to go somewhere, or that there's going to be chains somewhere, it helps if you can either make sure that there's a note there, or that you have added that in. And you can simplify it, like Ian was showing you with the e-board. They're boxes. That's fine. That's totally cool. You have a name of what the box is and the space it takes up, and that will actually help you a ton, because then you understand what components you need to go where. So that when you're making all of these parts and then manufacturing all these parts, you're not like, oh man, we suddenly have no space. Because you only have a set frame for armor, right? You can't just add on another 2 inches. The next thing I want to talk about is easily repairing things and or fixing things in the middle of the competition in manufacturing, and why that matters. So you've heard a lot about the manufacturing, you've talked a lot about repairability, right? And sort of your comfortability with tools. So let's say we're at competition and one of the components that we have a CNC breaks. What happens? Right, but let's say we don't have a CNC, right? Or these are things that you should consider when you're manufacturing your components, when you're designing your components, even when you're like testing and making them. If something can be easily fixed, that helps. And if it can't, you need to understand that too, right? If you can't get something down, if say for instance you have something that's completely buried beneath the robot, or to fix or repair will have you take it apart, I definitely would recommend thinking about that. Overall, it doesn't have to be your dictator, but when you're manufacturing everything, think about, okay, is this going to be, where is this going to be? And if you're making a prototype, then just keep making it, right? Like that's fine. But if it's going to be a critical component, so maybe you want to have it be more precise so that it doesn't break. Just the things to consider when you're going forward, right? The last one is, if you're making something that's super complicated, sometimes the odds are is that someone has already thought about some of the components and you can buy them. You have an amazing catalog that you can buy off of Vex Pro. I would highly recommend looking at. You have a few other places that you can sometimes buy some COTS materials that may simplify or make the design easier on you. And the reason I say that is, it's not that it's not cool to build really cool, complex things. You need to understand time. Time is the most,
How would you actually like find one of those pieces online? Like this complicated shape that's kind of indescribable. How would you find it? Or
so I guess the first thing is, what are you using it for?
Oh, okay, yeah.
That's where you start, and then you can drill down, is it a pneumatics component, is it a gear house? Cause maybe they have a gearbox assembled, maybe it doesn't exist.
There are a bunch of catalogs, so if it's like pneumatics, you can look at pneumatics catalog, McMaster is like a big general catalog kind
Yeah.
of. So you can drill down in a specific area. I mean, knowing the standard FRC parts can be useful, like looking through AnyMark and VexPro, because those are generally useful for FRC. If it's just a random part, like you're like, I want this shape plastic thing, then sometimes it just takes a while.
Yeah.
But,
Yeah, if you want a random bracket, there's some chance that it might be in the master, but just for the online, the catalogs for FRC, and these are kind of companies that are basically made to make FRC parts, are VexPro, so I guess we could probably link them in, but, like VexPro, I often order from West Coast Products, which is basically one of the Madtown mentors.
Yeah,
VexPro is like a Robo Wranglers and Thunder Chicken's mentor,
yeah.
and then,
And VexPro and West Coast Products have
Yeah,
some
shared-
partnerships, so
some
they
shared.
share the parts, it's kind of.
yeah, AnyMark is like a really old, one of the East Coast teams, mentors that makes a lot, like, they used to make the first COTS shifting gearboxes for FRC. And one of the older, not FRC specific, but, robotics-y things is, the BaneBots, catalog, so they make a lot of motors. They still make planetary gearboxes, but people don't use them very often. But people do use BaneBots little wheels, all very commonly. Yeah. Yes, they're very
2018.
useful
Yep.
for all kinds of stuff.
So, and then the last resource is ask someone. Like, especially these two, I have like some knowledge, but these two just like know these catalogs sometimes. So, if you're not sure, talk to someone on the team. Like, actually, sometimes the best resources, if you can't find it and you're like, I've been looking here, here, and here, talk to us after you've done a little research, and we might be able to help you. That's why we're here.